Let me get started. All right. Here we go. All right. So welcome y'all to another general meeting. Let me do the slideshow real quick. Awesome. So I hope everyone is having a good week. I know this is the week where classes actually start teaching stuff. You get homework and stuff. So good luck, everyone. I hope y'all have a really good rest of the week. But today, we're just gonna be over pretty much the same thing as we've done over the last 2 weeks, with the exception of a weekly lesson that we had from previous semesters. It's gonna be Carlos this week with recovery. He'll be explaining basically just the fundamentals of recovery today. So first, just still the COVID protocol. We need a negative test from anyone that wants to attend to a lab. You can easily get a test. I keep forgetting to change the CPR here on the slide. So I apologize for that misspelling right there. But you can get a PCR test on campus for free whenever you want. You can just schedule it. It's super fast. There's no lines. And then at the lab, there's still a 6-person lab limit with the exception of avionics. So please, if you come in contact with someone who's positive, just let us know. I'll wait a few days to get tested and just don't show up to a lab. For shout outs this week, there's a couple. The first shout out I want to give to is Ravi. Throughout the last week and a half, he's been working on the sponsorship package. If you don't know what that is, it's basically this document that highlights everything that AIAA has to offer, what they've done for their students, what the project teams are, and so on. And it just compacts all of it into this document that you send to companies or potential sponsors in order for them to sponsor our project teams and AIAA. And he did an amazing job. It's amazing. Um, thank you, Ravi, so much. I know him and Omar already started sending emails to a lot of the companies, and hopefully get back to us soon, letting us know whether or not they'll be able to sponsor us with either materials or with actual money. Another shout out is for Bailey. My brother wanted to shout her out because she's been working really hard with recovery, especially last week. This week. Thank you, Bailey, for continuing your efforts with the team. And then one final shout out will be to Raj. He received a perfect score in his ham radio tests. Now he is ham radio certified. Congratulations, Raj. That's amazing. You got a perfect score. I think he thanked Kurt for being such a great professor of ham radio. Okay, so for some announcements and deadlines, we have a huge one today. The biggest one, of course, yesterday, Gustavo, Ravi, Omar and I were on a call and we made the purchase of the motor. It's really expensive. The motor plus all the hardware was $2,400. The motor itself is like $1,500, and then the hardware was like $700. The way it's gonna work though, unlike last year with the Loki M3000, is with the Cicerone. Um, the hardware will be shipped to us, so we can have like the actual motor casing and we can test fit it with all our with the airframes and everything else, the boat tail. But the fuel itself, so the fuel grains, those will be shipped to us when we get to spaceport, and they will help us assemble it there. So we won't have the fuel with us at the lab or anywhere. We will only have the hardware, specifically the motor casing. So that's huge. So this makes it really official now. As we mentioned in the previous weeks, we've been ordering parts, and our recovery is going to get started with the bolt tail manufacturing this Friday. Recovery has ordered everything they need. So we're just waiting for everything to get to a lab so we can start the hands-on work. Another announcement or slash like this reminder is that our progress reports that we kind of did last year, they were like monthly ones, but since some months we didn't have much and we've been changing a lot of the things we've done, we're gonna have like a huge progress report due on February the 14th. with everything finalized and now getting started with the physical hands-on work. So I'll say in around a week or a week and a half. If you remember you want to get better when it comes to documentation, writing, technical reports, I would suggest for you to help out the sub-team lead. It's a great opportunity, something you can talk about whenever you have an interview. Tell them what you did for SCR. This looks great. Today, we also want to do a Jeopardy night. So kind of a trivia night where I'll be hosting it. I'll be like Aaron Rodgers when he hosted Jeopardy, only that never mind. I was gonna make a joke about him losing in the playoffs, but ignore that. So it's just gonna be movie Jeopardy night. It's gonna be, they're easy questions, and the way we want to set up it will be after the meeting tonight. I'll stick around, and anyone that wants to participate, you are welcome to. And then the person who gets the most answers right will get free pizza from Pink's from us. And that's an open invitation to whenever you want, whenever you're on campus. If we're available, we'll get you that pizza. And then one last announcement will be that we were supposed to have a Hearn like Tripoli launch on the 22nd, which was last Saturday, but it was unfortunately canceled. So now Hobby Rocketry is planning to go again on February the 12th. I go February twice. I want to encourage everyone to start like scheduling for that on the 12th. I think it's a great opportunity to get to know all the members of the team, hang out, see a bunch of rockets launch. And if you want to get your L1 certification, I think if you get started on that now, that would be great. That way you can launch on that date. And then on the top right here, it's just the thrust curve of the O3400. If you hadn't seen it before, this is it. And then this is just like a picture of how the fuel and everything's assembled. It's not quite exact, but this is kind of how it looks. Okay, so with all the announcements done, I want to move on into the sub-team updates. First off will be analysis. Analysis,
Yeah,
Ravi?
I'm waiting for the slide.
Oh man, I'm sorry.
Cool. So for analysis this past week, we're looking at fin design once again. And something Randy suggested was Concorde style fins. It's a potential fin design that may show improved drag characteristics and overall flight performance. So we're looking into that along with using fin flutter as justification for a fin design and not just stability or apogee. So we want to be able to say definitively that we chose a certain fin design, not just because it gave us a good stability and not just because OpenRocket or RockSim threw out a good predicted apogee. We want to say also because it was the best option available for fin flutter. And then also what we're working on is the boat tail FEA. Plan to have that complete by Friday, February 4th. Arturo and Omar are working hard away at that. And in the upcoming week, we're looking at updating documentation in prep for the February progress report. And then also looking at a potential wind tunnel project using a scale model of Zenith. The new fluids professor, which I know a few of us have, including myself, Professor Florian mentioned that he's either in contact with someone at U of H who has a wind tunnel, or I think his lab may also have access to that. So I'm gonna reach out to him and see what we can learn from a potential wind tunnel project.
Thank you, Ravi. Next up, avionics.
Hi everyone. For avionics this week, so far we just finished printing the prototype for the avionics tray. Thank you Gus and Irvin for that. As you can see here on 3 pictures, it's pretty much the same dimensions as last year, just with an orange PLA. We're mainly going to use this as a prototype just for our basic testing and to see how everything works out for this new year. On the next on our list, our accelerometer has finally arrived inside the lab. It's in the black Adafruit bag. Again, thank you, Rafi. Thank you, Gus. Thank you, Irvin, for helping ordering that and getting that in stock for us. And we also met with Recovery to talk about mainly our bulkhead adjustments. So far, it looks like we'll have enough space to sort of enact our last plan as last year with is basically the same type of ignition system except with an SRAD ground station and also a couple things as well. This Thursday we are going to do a lot of coding with ground station. So if anyone is experienced in Python or has a really good amount of coding knowledge in general, I'd invite you to please contact me and Joe, and we can and if you can join that Thursday meeting, that'd be awesome. We're going to do a lot of hard coding with the ground station from scratch, so that'll be really useful for us. Other than that, that's it for avionics.
Thank you, Raj. All right, so payload.
Hey everyone, I hope you had a good first week. Our lab will be Thursday at 7 p.m. Our virtual meetings will be Wednesday at 8 p.m. There's no major updates from this first week just because we're still getting into our first lab for the semester. But our upcoming is we'll be finalizing any further math and physics needed for the lens, whether it be for the objective lenses or specifically for the GoPro, and then we'll match it to the corresponding lenses from our research and purchase that. Therefore, we'll be doing some in-person practice of image focusing in the lab, and then we'll confirm the type of LEDs we need so that Drew can bring that in. We'll need to update documentation, which will be on me with task agreements and the progress report coming up. Our purchase order will be in this week, so we can get started soon. And then an in-depth review of assembly and data analysis and any statistical code we'll need to do for bio.
Thank you. All right, recovery.
So for recovery, it was once again kind of a slow week. Now that the semester has actually started, hopefully we'll become a little bit more active, especially as components start to come in. But we did decide on a weekly meeting time, which is going to happen Thursdays at 6 p.m. online. We purchased all the recovery components last week, and some of them started arriving. We also talked to avionics about conducting the CO2 system test because we do have 2 of them, and we just want to narrow down not only which specific model we're going to use, but also to see which cartridges we're going to use. And upcoming is just writing the procedures for the CO2 system test. Since everything looks to be okay, we just need to have a plan. So whenever we do conduct the test, we know what we're doing and we can work efficiently and get the data that we need. Other than that, I think that's it for recovery. And to answer your question, yes, Ravi, you can definitely help us out in some way. So I'll reach out to you.
All right, thank you, Carlos. Structures.
So pretty much we determined our second lab time was going to be Saturday from 2 to 5, just as like kind of a backup if we need it. The motor block, Ethan sent me a video. He's already started making it for us. I would have linked the full video, but I worried it was going to be too loud. We are also beginning the production of the boat tail this Friday. We do still need to purchase a few more materials, go ahead and reprint our model for it, and then just go ahead and finalize, make sure we fully understand the procedure that we're going with. But yeah, we'll be starting this Friday. And there's been discussion about potential testing with the bulkheads. That's all so far this week.
Thank you, Haley. And the recovery lesson, but before that, let me see if I can show y'all the schedule right now. Let me just get rid of everything else. So this is how it currently looks. This is the right time. Yep. So these are the times that we have for everyone. The only ones that we're missing here is propulsion. But soon as we get that sorted this Thursday, we'll add them here. All right, sorry. Now let me get back to you. If anyone wants a screenshot, just let me know. I'll screenshot it. And take it away, Carlos.
All right, so I haven't practiced this, so I apologize in advance if it's not good, but let's get started. So I guess the first thing is, what is recovery? It is kind of self-explanatory, you know, it's basically just recover the rocket, but I think you can define it better if you think about the problem. And the problem is that you have a rocket that's really high up in the air that you need to recover. And it's going to come down, you know, the only force on it is gravity. So the solution is recovery. And that is the way that you retrieve the rocket after launch. And whatever goes up comes down. So I think that a lot of people kind of overlook rockets. They only think about like the cool part when it's going up, and they see like the burn of the rocket and it looks pretty cool. And they kind of don't think about the way that it's going to come down. And that is our job. That is recovery's job. And our goal is to retrieve the rocket in a capable flight condition. So that means recovering the complete rocket with minimal to no damage. And additionally, since we are competing in the Spaceport America Cup, that also means abiding by the IREC recovery design guidelines. So overall, if you just took what we do, those are like basically it. Most recovery systems work the same way. They work by storing a slowing mechanism until the right time. If you look at the figure here, the one on the bottom, you can kind of see like all the events that happen during a rocket launch. So the storing mechanism is not triggered until apogee, and that's when you would deploy your drogue parachute, which is the smaller one. And then finally, once you're closer to the ground, you would deploy your main parachute. And the point of the parachutes, kind of self-explanatory, but it's just to slow down the rocket so it doesn't take any damage and you can recover the rocket. So there is a lot to recovery. There's a lot of different components and hardware you can use. This is just some of the components that I thought about, but there is a lot of different combinations of hardware that you can use. And there's a lot of things that you have to consider. So this is just a list for anybody who's interested. Unfortunately, this is just like a quick overview. So we can't cover like all of these different things. So maybe later in the semester, I'll go more into detail, but this is just like a list, a quick list. So the way that we have the recovery subteam structure right now, we kind of have divided it into two different roles. So there's the ejection, which is when you physically split the rocket, and their role is to basically design the best ejection system, choosing the best configuration for the ejection system, deciding how the bulkhead is going to look, performing ejection tests, and making sure that it would work under low pressures, especially since we're going to 30K. And then landing is pretty much everything else. So deciding how the course are going to look like, what parachutes we're going to use, how fast do we want the rocket to descend, all those different things. That's what the landing crew is responsible for. Next slide, please. So a little bit more detail about ejection. So you can see here that there is pretty much 3 different types of ejection methods. The first one relies on pyrotechnics. So that means black powder or smokeless powder. And those are the first 2 pictures there. You can see the one on the top left, that's closer to what we had for Oberon, where it's a black powder charge, where essentially you provide an electric current that lights the black powder, and then the black powder ignites, which produces a lot of gas, and then that gas produces a lot of force, which breaks the shear pins, which is what's keeping the different sections of the rocket together, and then it pushes them away from each other, and then that allows the parachutes to deploy. Then on the middle picture here, that is a CO2 system. They were kind of similar, using a pressurized gas, but I guess the point of a CO2 system is that they're supposed to be more reliable because they use a smaller amount of black powder, which is kept in a little chamber, which makes it, or supposed to make it work better at higher elevation, sorry, because as you go higher in elevation, there's less oxygen in the atmosphere. So that black powder that's kept in a chamber pushes a puncture piston, and then that makes a hole in the CO2 cartridge, and then that pressurizes the recovery bay, which then splits the airframe, and then that allows the parachutes to come out. And then the last type of recovery ejection system are the mechanical separation system. That one you can see there on the bottom, and those, like the name suggests, kind of works. It's really broad, but it relies on using different hardware to physically push the different sections of the airframe together. Those tend to be more complicated, so you typically don't see them, but they are pretty cool and they are safer because they're not using any explosives. And some of the requirements, constraints, and challenges that you have to consider with an ejection system is the redundancy. Actually, one of the most important requirements that we have to consider or follow is that you need 2 different completely independent recovery ejection systems, because if one of them fails, you can rely on the other one working, so you decrease your overall chances that your recovery system doesn't work and you lose the rocket. Some other things are reliability, price, performance, and price. And then a little bit more about landing. The purpose is just to slow down the rocket to a safe rate. As you can probably guess, the most used method for this is parachutes. There is like different ways of slowing down a rocket or anything that's falling without the use of parachutes, but they're not really common. There is 2 different sort of parachutes. There is the drogue and the main. The drogue is smaller and is only intended to slow down the rocket while minimizing drift and the recovery time. So let's say you hit apogee and you deploy a really big parachute. If you deploy it at 30,000 feet, then it would probably take hours for the recovery to come back down, for the rocket to come back down to Earth. And you don't want that. And then it would also like fly really, really far away, like horizontally. So that's the point of the drogue. And then when you're closer to the ground, you deploy your main parachute, which is bigger. And that one slows down the rocket significantly. So whenever it does hit the ground, it doesn't take any damage. Some of the parameters you would consider for parachutes are your coefficient of drag, your size, your cost, your snatch force, your packing volume. And you can see here, the table and the formula underneath, that is part of the calculator that Recovery made last semester. And that allows us to compare different parachutes, but it also allows us to make any changes, like let's say the rocket becomes lighter or heavier, we can change the weight of that, and then it will tell us the descent rate as well as the snatch force. You've probably heard me say the snatch force like a million times, but all that is the force of, or the force created by the parachutes when they first open up. There is a high rate of deceleration, which creates a lot of force, and that impulse, if your components are not strong enough, they can either tear the parachute, tear the cords, or just rip the rocket apart. So it's one of the biggest parameters that you have to consider, and you have to make sure that all your components can withstand that value, because else you pretty much risk losing your rocket. Some other landing components are your cords, your quick links, your U-bolts, your swivels, and your tender descenders. We're going to be using tender descenders this year, which I don't think we've ever used in the past, which is exciting, but they are a little hard to explain, so we'll just save it for next time. Next slide, please. Here are some sources if you want to learn more about recovery. I really hope that we have time later on in the semester so I can go more into detail, but I would really suggest watching that first video there. It's probably like one of my favorite YouTube videos ever. I watched it so many times. Not only is it like a good YouTube channel for learning about recovery. No, it's not Jim Jarvis. If Jim Jarvis had a YouTube channel, I would definitely be subscribed to that. But it's by BPS Space. He makes a lot of cool like rocketry videos, but that one just pretty much nails like everything there is to know about recovery. So I would really suggest watching it. And then I also made a overview presentation of the recovery system for this year a couple of weeks ago. So if you want to learn more, you can also watch that. There's a link to our calculator. And then at the beginning of last semester, when we got all the new members, I made 3 other presentations that kind of go over basic information about recovery if you want to learn even more. But for now, that is it. Thank you for sitting and listening to me.
Virtual claps for Carlos. Thank you for the presentation. I do have a question though. And anyone else can ask questions after I go. Are there any other methods of separation besides the 3 that you mentioned? For example, an airbag.
I mean, there's no real like defined or like concrete definition of like mechanical separation. So maybe you could group it under that, but I guess black powder and CO2 have their own category just because they're so common, but airbag, that could work. Airbags, I actually thought about that like during the summer. So I did some research and they have like, there's some other chemical that they use and it doesn't use any oxygen or anything like that. Like it's just those chemicals. So you can actually make a recovery system that uses the same chemicals.
Any other questions?
Ravi, you have a question, right, Ravi?
Yeah. You mentioned that there were ways in which to slow down the rocket after it hits apogee other than a parachute. What is, I don't know if you've done much research on this, but what are the kind of like the coolest methods you've seen that are not parachutes?
Actually, I have done my research. No, I'm just kidding. I do know that if you use tender descenders, or there's also these like, okay, so the parachute, they come in a deployment bag, right? So there's some people, or you can buy these things that are called cable cutters that keep the bag shut. And you can use the main parachute still in the bag as the drogue parachute. So technically that's not really a parachute, but there is these other things that are called reefers, and they're just like these really long strips of fabric, I think, and you can use them on like smaller rockets, but for something as big as Zenith, I don't think you could use them. But yeah, they're just these like really long fabric strips, and then whenever you hit apogee, it deploys or whatever. And I think it's supposed to make like a lot of noise because it's just going like this in the air, but it produces like enough drag to slow down the rocket. So there's that. But yeah, I think by far that is like parachutes is just like the easiest way to go about it.
Thank you. That was very informative.
Would you say that is it possible to put a drone in the rocket and deploy a drone to carry the rocket?
I think that's a payload question, not a recovery question. But
Interesting.
I don't know. Maybe
Can you do a SpaceX recovery?
it's a SpaceX recovery.
Yeah, a reverse.
I'm not that smart.
What if we just lay down a bunch of pillows and guess where it'll land and then just hope for the best?
What if we have a pogo stick at the back of the rocket?
All these great ideas. Why didn't y'all say this before we finalized our design?
Capstone question mark? Ravi, you want to take that on as your capstone project?
Dude, I just might. Thanks for the idea.
All right, we're gonna leave it at that for the questions. If you have any other questions about recovery, feel free to ask in the general channel. Carlos will be very happy to help you out. Any other questions about the team, about anything coming up anytime soon? Gustavo, you have anything you wanted to add? Or anyone?
I have a question.
Yes, what is your question?
So today U of H announced that next Monday, January 31st, January 31st, jeez, we're going back, like the soft opening ends. So are there plans for in-person meetings again, or are we just sticking virtual until a certain time?
So the original plan that we had was to just keep everything online for like the first 3 to 4 weeks. We'll have to have that discussion again in like a week or two to see where we stand. But we don't have an answer yet. As soon as we come up with a decision with Gustavo and all the leads, we'll let everyone know. Oh, one thing I did want to bring up is we are planning to have an SCR bake sale sometime this upcoming week or the one after. I'm not sure when exactly it's going to be or what we're going to be baking, but just keep an eye on that. We'll probably be in the student center, a couple of us. So if you want to go and support and just have a snack or something and buy something to support the organization, please do so. Whenever we get more information, we'll let everyone know in the general chat. But
Yeah, somewhat off topic and much further down the line, but there is a question bank for everything about Zenith that has not been answered. So if you guys want to like go through and answer what you can, or just look through and I guess learn about what other people are doing, that is a super good resource to be filling out and taking a look at. I'll post it on the chat for you guys.
yes, Carlos Soriano, what's your question?
My question is, can we type in that document? Because I was looking at it earlier today and I didn't know if like we could answer the questions or not. So
Yeah, go ahead and answer them. And then I guess I'll make a copy before you answer anything so we can have it as like little handouts if people want to make a printout and like quiz themselves.
okay, thank you.
Anyone else? Any questions? Any questions? We still got to change this. All right, well, if there's no questions, I'm gonna stop sharing my screen for like half a second so I can set up the Jeopardy. So if you want to stay, and I encourage everyone to stay just to play, it's gonna be like a movie Jeopardy. Please stay. It's gonna be fun, I hope. Let me just set it up. Oh
Hey, look, that's
man.
a piece of gum right there.
Oh man. All right, give me 1 second. You cannot minimize the Zoom. All right, let me set it up.
Do you want to keep recording, Irvin?
No, yeah, I don't want to keep